Hi, this is Rich from ShotoTechnologies. We decided to put together another video to show how the ShotoLab system can help you in your laboratory. This time, we needed to do some hydrogenation reactions, some pressure reactions, and this video is not to show you how to do the reactions, but how the ShotoLab system can help you in your lab in carrying out this type of reaction. The ShotoLab system allows you to do very cost-effective reactions. You could go to Power Instruments and order your own autoclave for $10, $15, $20,000, but we put together this little reactor from 316 stainless steel pipe fittings ordered through McMaster-Carr for less than a tenth of the cost of something through Power. In this video, you're going to learn how to make this reactor that we just showed you, and the ShotoLab system will control the temperatures, and it will also monitor the temperatures and pressures throughout the course of the reaction. The reactor assembly is relatively straightforward. Here you can see a picture of all the major components. On the top left, we have some thermocouple wire. Underneath that, we have some heat resistance wire to heat the reactor. There's various 316 stainless steel pipe fittings that are going to be assembled. We use a magnetic stirrer to stir the reaction. We have a 1/8" stainless steel thermal well along with a pressure relief valve for setting the pressure in the system. And then there's a proportional solid state relay which is used to control the temperature of the reaction. Assembling the reactor is relatively easy. Here's the components, the pipe threads with Teflon tape wrapped around the threads. The first thing to do is add the end cap. Simply screw it together. Then add the T. And this is how I take it apart. This is where I take it apart to add the reactants to the reactor. After adding the T, insert the two reducing bushings. These go to a 1/4" NPT fitting. Then I add in a 1/4" NPT to 1/4" swage lock fitting. Add the thermal well, but don't forget to insert the stirrer if you're going to be doing some stirring. Then add the thermal well. This is an 1/8" thermal well fitting. And here's the final product. And here you can see the completed reactor. You can see we've added the resistance wire. We wrapped it around the base of the reactor for heating it. We've added thermocouple wire between the heater and the reactor itself to monitor the temperature of the heater. We've added a thermocouple wire to the thermal well to monitor the temperature of the reaction. We've added a pressure transducer, the pressure relief valve, and a 10-turn valve to be used to open and close the system for removing or adding gases to the system. Next, we want to just show you the connections to the Shoto boards. It's relatively easy. The first terminal block is, as you look at the top terminal block, there's a green wire. It's a ground wire that's going to the solid state relay. On the right, there's a blue wire that goes to an analog output, which is used to control the solid state relay. And you can see this little black wire. This is used to monitor the output voltage of the analog output. And then the green and the white wire are the outputs of the pressure transducer. The middle terminal block has the three thermocouples that we're using to monitor the temperatures of the system. We're monitoring an ambient, the heater, and inside the reactor itself. And the red and black wires on the bottom terminal strip, these are the power supply for the pressure transducer. We're just using the 5-volt USB outputs. So as you can see, it's relatively low voltage. Next, we have the solid state relay connections. The two terminals on the left are the 120 volt AC voltage that are used to heat the resistance wire. On the right, there's a little terminal block, and again, the blue wire goes to the analog output on the control board. The green wire goes to the ground, and then these two orange wires, these are 15-volt supply voltages that are used to control this relay itself. So let's run the system. All we have to do is enter a value, a voltage value for the heater, and that will turn the heater on. And we're going to just enter a value of 1.4 volts and see what happens. This green line now is going up. This is the temperature of the heater. And as soon as we turned it on, we got an immediate response. And the reason for this is that that thermocouple is right on the heater. So as soon as you turn the heater on, it immediately heats up, and after a couple of seconds, you can see that the temperature is well over 100 degrees C. And this is a real-time response. This isn't sped up or anything. And this is one of the great features of the ShotoLab system. It gives you simultaneously plotting of all your data, so you can see what's going on in the system itself. And here you can see the green line, the temperature of the heater is continually increasing. And it actually get a little boring if we were to continue to watch this in real time. So what we're going to do is jump ahead and see how the system performs over time. Okay, after a couple of minutes, you can see that the green line, the temperature of the heater, continues to increase. The red line is the temperature inside the reactor, and that's going up right now. It's also over 100 degrees C. And on the bottom, you see this little blue line. This is the pressure, and you see that the pressure is also increasing. Again, with more time, you see that the temperature inside the reactor, the red line, is kind of stabilizing. You see that things are progressing well. And now here's the end of the reaction. At the end of the reaction, you can see that the temperatures have stabilized, and the outside of the reactor temperature, the green line here, kind of stabilized at about 475 C. The red line also kind of stabilized throughout the course of the reaction. After turning off the heat, you can see that both are dropping now. And this blue line on the bottom, which is the pressure, that kind of stabilized throughout the course of the reaction. And we're going to just look at this data in a little more detail. Another nice feature of the ShotoLab system, all the data is stored for some data analysis. So let's look at the data. Let's pull up all of the data from the run and see how it looks. Now this is all of the data from the run. You can see the green line for the heater, the red line for the reaction temperature, the blue line is the pressure, and various other parameters. But here's what's interesting. Let's just look at the pressure. Let's just pull up the pressure line. And you can see on the left here, this little blip. When we turned on the heat, the pressure went up, and then it went down, and then it went up again. This is an anomaly that has been repeated over several reactions, and what we need to do is investigate to see what's going on here, because this might actually give us some insight as to some important features with respect to the reaction. But after that, the pressure kind of, followed the relief valve. And it was pretty much typical of what we expected. So this is what the ShotoLab system can do for you in doing some pressure reactions. And what we're going to end up doing is doing another video. We're going to put 5 of these reactors together in a system so that we can do some multiple scans and try and find and optimize this process. We'll put together a video in the near future of that as well. Hope you enjoyed the video, and hope you enjoy our future videos as well.